An understanding of our atmosphere is fundamental to a pilot, since it is not just the air we breathe, but the environment we fly in. This environment can be benign, but equally so very hazardous. There are many physical processes at work within our atmosphere, and these need detailed analysis. These processes will be covered in the following lessons, but for now let us examine what the atmosphere is and what are its main properties. The word atmosphere is defined as being the gaseous envelope surrounding a celestial body. In the case of the Earth, it is the collection of gases that are held around the Earth by gravity. There are well over 20 of these gases, some more abundant than others. We will concentrate on the 4 most abundant gases. By far the most common gas is nitrogen, which accounts for about 78% of the atmosphere. Oxygen, which is essential to sustaining life and the proper functioning of internal combustion engines, makes up 21% of the atmosphere. Just less than 1% is argon, with carbon dioxide making up the rest. There are many more gases making up our atmosphere, but these are found in such small quantities that we regard them as trace gases. These include carbon monoxide, helium, methane, ozone, and hydrogen. However, one of the most important gases with regards to meteorology is water vapour. Without water vapour, there would be no weather. Even though it is found in very small quantities in the atmosphere, it has by far the greatest effect on our weather. Clouds and rain are examples of its liquid state, whereas snow and hail are examples of its solid state. The relative amounts of the gases stay fairly constant up to about 60 kilometers above the Earth. Thereafter, gravitational separation alters the composition of the atmosphere. In order to structure our atmosphere into various segments or layers, there must be a property of the atmosphere that varies with height. The variable we use is temperature. The first of these segments or layers is called the troposphere. This layer is closest to the Earth, and its defining characteristic is the marked decrease in temperature with height through the layer. Because of the effect of gravity, this layer contains over 70% of the total mass of the atmosphere. The altitude where the temperature no longer decreases with height defines the upper part of the troposphere. This upper boundary we call the tropopause. The thickness of the troposphere, and therefore the height of the tropopause, is not constant across the Earth. Over the poles, the height of the tropopause is about 8 kilometers, whereas over the equator it is about 16 kilometers. The average height is 11 kilometers or 36,090 feet. This is the case at about 45 degrees latitude. The reason for the height change in the tropopause is simply due to the surface temperature. Where the Earth is warmest, near the equator, the tropopause is at its highest. Looking over the poles where we have very cold air, you can see the tropopause is at its lowest. We know that temperature decreases with height within the troposphere. Therefore, the further away the tropopause is, the colder it is. Over the equator, the tropopause temperature can be minus 80 degrees Celsius, whereas over the poles, the tropopause temperature is only about minus 40 degrees Celsius. However, the average temperature is approximately minus 56 degrees Celsius, which is common in the mid-latitudes, where the tropopause is approximately 11 kilometers. Having discussed the troposphere and its upper boundary, the tropopause, we will now look at the next layer in the atmosphere, called the stratosphere. This layer is characterized by the lack of any significant change in temperature with height. The stratosphere